Welcome all of you to the design of concrete structure lab of 5th semester civil engineering. So today we will discuss about the cube test of concrete, that is nominal mix. So in this experiment we are first going to mix concrete of a definite proportion. After that we will discuss how to perform the cube test. So before proceeding further, we must know that what is concrete. Concrete is nothing but the mixture of cement, sand, fine aggregate and water in a predetermined proportion. So for making concrete, we'll mix these four things: cement, sand, that we call in our civil engineering as fine aggregate, coarse aggregate and water in a predetermined proportion. What does we mean by that? We mean by that before mixing these four things, we will finalize in which proportion we are going to mix these things. For general RCC works, for general reinforced cement concrete work, RCC work, the grade specified by IS 456-2000, that is our code for concrete, is M20. The grade of concrete should be M20. So in this thing, M20, M stands for mix. M stands for mix and 20 stands for stands for 20 Newton per mm square. We call it characteristic compressive strength. So for performing this experiment, we have to decide what should be the proportion. So this experiment is for nominal mix. So what is nominal mix? Nominal mix is a prescribed mix. Like we go to a doctor, he writes something, we call it prescription, like that. This proportion, what we are going to do in today's lab, is a prescribed one. Means it has been prescribed previously. We are doing nothing new. So for M20 grade concrete, the proportion is so this we read as 1 H to 1.5 H to 3. So what is this 1, this 1.5 and this 3? 1 is cement. But what should be the unit? The unit should be kg. The cement, whatever we are going to take, is measured in kg, and kg is the unit of mass. So here this proportion 1 is to 1.5 is to 3. It stands for proportion by mass, means it is in kg, it is in kg, it is also in kg. So for M20 the proportion is 1 is to 1.5 is to 3. Suppose I will be taking one bag of cement. One bag of cement is has a mass of 50 kg. So suppose I will take 50 kg of cement, then my proportion for nominal mix should be 1.5 times my proportion for sand. This 1 is for cement, this 1.5 is for sand or fine aggregate, this 3 is for coarse aggregate. So 1 is for cement, which is 50 kg if it is one bag, 1.5 is sand. So what will be its amount? Its amount will be 1.5 times of cement. So it is 50 kg. 1.5 times of 50 kg is nothing but 75 kg. 50 into 1.5 is 75. So 3 times. This is 3 times. 3 times of what? 3 times of cement, which is 50 kg. So 50 kg into 3. 50 kg into 3, which is nothing but 150 kg. So finally we have cement 50 kg, sand 75 kg, and coarse aggregate 150 kg. Now let us see the things. After that we will see what amount of water we are going to add. So this is our cement. For demonstration purpose we have taken some amount of cement. So this is our amount of cement. Let it be, say it is 5 kg. So if it is 5 kg, then what should be the amount of sand? The amount of sand should be 1.5 times. So 5 into 1.5, which is 7.5 kg. And after that we have to mix coarse aggregate. Here we can see the coarse aggregate. So if I have taken 5 kg of cement, the amount of coarse aggregate should be 3 times of that, which is 15 kg. So normally which size of aggregate we should take, that we should know. This is our IS sieve. We can know what is the sieve size from here. Here the sieve size is 20 mm. So what is this 20 mm? You can look here. Here there are different openings. This. These are different openings. All of them are squares. This is a square. This gap, this is a square. It is 20 mm, means if I will say in centimeter, it is 2 centimeter. This length is 2 centimeter. This length is also 2 centimeter. It is a square. So we measure it, we read it as 20 mm, not cm. So this is our 20 mm sieve, sieve. So normally for our RCC work we take 20 mm nominal maximum size of aggregate. So what is 20 mm nominal maximum size? Let us take some aggregate. This we call as scoop. This is called scoop. In that we can take some aggregate. I have taken some aggregate. I have put it on the sieve. So we can see not all the aggregates are passing through it. Let us shake the sieve. This process is called sieving. Normally it is recommended that this sieving should be done in a mechanical mixture. But for demonstration purpose we are doing it in hand. So now you can see some coarse aggregates are retained. So what is retained? Means it is not passing through the openings, sieve openings. So these aggregates have a size more than 20 mm. We call it 20 mm up. If a single piece of aggregate is passing through the opening, then that aggregate we call it as 20 mm down aggregate. But here our nominal maximum size which we take for RCC work is 20 mm. So what is nominal maximum size? This sieve size is 20 mm. Suppose I am taking some aggregates. I will take some aggregates. All of them will pass through it. All of them will pass through it. But it will be retained in the next sieve. Here, start. So now we have taken some aggregates for demonstration purpose. So now I am shaking them in hand. So we can use different type of hand motions if we are sieving by hand, like this, circular motion. So we can give different type of motion. So now some aggregates have been retained in the top sieve which is 20 mm in size, and some aggregates have passed. Let us see. These aggregates are retained in 20 mm, means they have not passed. They are above the sieve. We call it retained. Now see these aggregates. These aggregates have passed through 20 mm sieve. Suppose I have taken 1 kg of aggregate. Suppose I have taken 1 kg of aggregate, then 10% of it is 100 gram. Suppose I am sieving 1 kg of aggregate, and in 20 mm all the aggregate passed. But in the next sieve, which depends on the availability of the laboratory, the next sieve, if say all the aggregates are retained, means the aggregate could not pass through the next sieve. So what is nominal maximum size? Nominal maximum size is one sieve size larger than the aggregates which are retained on the next sieve of 20 mm size. So we will take some amount of sand. Suppose I am taking 50 kg of cement, as we have discussed earlier. The amount of sand should be 75 kg. but here we have not calculated yet what amount should be needed for our design. Now only we are focusing on the mixing procedure, how we are going to mix. So you will take the required amount of sand and you can put it in a non-porous mixing plate. So now I have taken some amount of sand. Say this amount of sand is, say we have taken 1 kg of cement, so the sand amount should be 1.5 times of that, that is 1.5 kg. So before mixing the concrete there should be dry mixing and cement. So first of all we can take the required amount of sand and cement. So now we have taken 1 kg of cement and we have put 1.5 kg of sand. Then we can mix these materials. We can use 2 trowel. This thing is called gauging trowel. We can use 2 trowels to do the mixing simultaneously. So now let me mix with 1 trowel. First of all, we have to mix the thing thoroughly, mix the sand and cement till we get a uniform color. Now we have got a uniform color here. So after mixing the sand and the cement, we will put the required amount of coarse aggregate in kg. So here say I have taken 1 kg of cement, then I have to take 3 times more coarse aggregate. So 1 kg into 3 is 3 kg. So 3 kg of coarse aggregate we can take. We are taking some only for demonstration purpose. Some amount of aggregate we are taking. So now, after putting all the things into the mixing plate, you can mix the things. For quick mixing, you can use 2 trowels simultaneously. In both hands, you can use 2 trowels and mix quickly. after mixing we can add some amount of water. So what should be the amount of water? Here we have taken a measuring cylinder or measuring flask, you can say. So here what amount of water should be added? The water cement ratio, as we have already studied in third semester in concrete technology, the water cement ratio is recommended from 0.45 to 0.5 times that of cement. For example, suppose I am taking 1 kg of cement, then maximum water cement ratio I can take 0.5. Means if I have taken 1 kg of cement, in that 1 kg I can mix maximum 500 gram of water. Okay, we should not be confused that water is measured in liter. Then how can we find what should be the amount in gram? So this is a measuring flask. First we can put it into a weighing balance to know its mass. Suppose this flask is 200 gram. This flask is 200 gram. What water I want? What amount of water? That is 500. So if I will pour water in it, this flask is 200 gram, its mass is 200 gram, then plus water 500. So finally I will be getting a reading of 700 gram. 700 gram in the weighing balance. Then what is the mass of water? The mass of water is 500 because this flask is 200 gram. So that 500 I can add here in my mix. But you should not add all the water at a time. You can add little amount of water and you can mix. Actually in this laboratory we have demonstrated the hand mixing procedure, but hand mixing is not recommended. We recommend a machine mixing. We have a mixing machine and it is recommended that the mixing should be done in that. So here we have the mixing machine. It is also called concrete mixture. You can put all the materials here, and after putting all the materials you can add the required amount of water, which is maximum 0.5 times of cement, but maximum is not recommended. We can take a value of 0.45 to 0.5. So if you are mixing in a mixture, you can add all the materials, but before adding all the materials, make sure that the mixture is cleaned properly. After a proper cleaning, you can add all the materials and you can mix. As per IS 456, Indian Standard Code 456/2000, the minimum mixing time should be 2 minutes. So we can put all the materials into the mixture, then we can add water, then we can mix, and after 2 minutes we can put all the materials into the mold. So after a proper mixing, okay, how to know the mixing is proper or not? After a mixing of 2 minutes minimum, we should look into the color. The color should be uniform. The color of the concrete mix should be uniform from everywhere. Means it should look the same wherever we take a look. That mixture we can put here in the mold. So let us take an inside view of the mold. Okay, we'll put all the materials here. Start. So before putting the concrete, we can use grease. We can use grease in this mold, so that after pouring the concrete into the mold, when we will take the mold out after 24 hours, it should not stick into the inside surface of the mold. The concrete should not stick into the inside surface. For that we use grease, or we can use some varieties of oil also, whatever is everything into the mold. So after putting everything, some amount of concrete should be going out of the mold. So what to do? We can take a trowel and we can level off the surface. Here is the concrete I have poured. We can level up like this, so that the top surface will be smooth and even. So after doing all these things, we can put the mold in vibrating table. So after doing all the things, means leveling of the concrete, we'll put that thing in vibrating table for a proper compaction. So what we'll do, we'll put the mold in the vibrating table.